Hello and welcome back to the series where we are creating a custom programming language from scratch using C++, Bison, Flex, Google Test, ICU, Doxygen, Vim as our IDE. My name is Corey, and happy Halloween. That is, it happens to be Halloween night when I'm recording this. I am in my Halloween costume. That is, I'm dressed up like my chair. So, and I think it's funny, Anyway, okay, so what are we going to be doing today? This is, what episode are we on? I should have looked. Episode 22. And we are going to be writing or supporting code blocks. So far in our programming language, we have only been supporting an expression. We don't have variables yet because we need statements and assignment operators and variables to be able to for it to do anything helpful. But in order to have that, we've got to have code blocks. We've got to be able to say a is equal to 3 and then give the result of whatever the result should be. And so we've got to get started with the code blocks. I wanted to try to do variables and an assignment operator and all that stuff today. And I started looking at what all needed to be done. And I try to, for each one of these videos, we try to break them down into a small enough chunk that you can, that it will compile and be in a stable state at the end of the episode. I thought it was just too much. I could do it in a day if that's all we were doing, but I'm hoping I can do it in an hour. It might take an hour and a half. We've seen how that's gone before, but we're gonna just jump in and see how far we can get. As always, we are picking up exactly where we left off. If I say get status, there's nothing there. And if I say get log, the very last thing that was committed was episode 21. So that is where we are. And yeah, let's just jump in. First of all, we got to talk a little bit about the structure or about what we've been doing. How have we been getting values out of our programming language? And the answer is, well, there's something on the stack. We write an expression of some sort, and it leaves something on the stack. It leaves an integer, a garbage collected value, right? Our stack is filled with garbage collected values. And as we do things, we've seen our bytecode, right? We may push multiple things onto the stack, and then as we do operations, it pops them off. But the last thing is it always leaves the result on the stack. So what does this mean for our overall structure? What if we have multiple statements? If you have 5 statements, you don't want to have 5 things on the stack. So we need to be able to remove something from the stack. It's like if I say we don't have variables, we don't have assignment, but if I say a is equal to 3, we need to be able to push a 3 onto the stack, assign it to a, but then that value of 3 will be on the stack because that would be the just like any other programming language. If you say a is equal to 3, maybe you want to say, some variable foo is equal to a is equal to 3. Well, you would assign the 3 to a, and the 3 would still be on the stack that you would then assign back to foo. You want to be able to support things like that. So at the end of the assignment operator or whatever, there is something on the stack, and we need to be able to pop it off so that we can then go on to the next statement. So we've got to have an opcode to pop something off the stack. That shouldn't be too hard. Just add an opcode. Then we need a structure to hold multiple statements. That's going to be harder. Well, I mean, not too hard. It's just an AST node, right? And it's an AST node that will hold other AST nodes, right, in order. And you think, well, maybe it's a vector. Yeah, that's it. And I think we can do it that way. And what else do we want to say? For right now, that's, well, we're going to have to come up with how do we want to, how do we represent that in the grammar, bison, right? We're going to need to add some stuff to flex. A semicolon. You say, Corey, okay, take for example, the language JavaScript. Doesn't have to have a semicolon at the end of a line, but it could, right? It's optional. I've never liked that solution. Some people don't like semicolons because it's like, oh, you forget them and the thing breaks. Yeah, you should have good error messages in that case. But then there's the other side of no semicolons whatsoever. And then that forces your code to always be on one line, or you have to add an odd, backslash or something at the end of the line. And there are plenty of languages that do that. You can write this however you want. I personally like the way semicolons work. They're familiar, of course. So I'm not going to downplay that. They are familiar, but they're very functional. They work very well. In the same way that my code block, or I plan on supporting code blocks, right? So that would be a semicolon. No, semicolon. No, my brain stopped working. How do I want to say that? Yeah. Sorry. Yeah, my brain stopped working. Did you notice that? I forgot what I was saying. Oh well. That happened. It's been a long day already. I've been programming at my day job, and anyway. All right, so we're just going to jump in. Yeah. That's what we're going to do. We're going to jump in. All right. We are, there we go. I said we need to add an opcode to pop something off the stack, right? So in order to do that, let's edit our include opcode. That's fine. And you know what? I think I want it to be the very first opcode. And we're just going to call it pop. Pop. A vowel. Sure. Simple as that. Of course, we need to edit the source program dump. And we're going to say for this, no. Pop. Caps lock again. There we go. We don't need to do the dump program check. We're just going to output pop. Yeah. That's all I need to do there. This can be a plus PC because it's just one operation and break. Okay. So that is our instruction for popping. And now let's edit the source for program execute. And again, it's our very first one. In this case, I'm going to steal the opcode for add just because it has the stack check in it. There we go. Okay, that didn't work. And that should be pop 1, and all that we have to do is That. Yeah. Simple enough. Hey, we have a new opcode called pop. Now we need to... Let's do flex. We need a semicolon. Well, we can start off with bison and then go back and forth. I think I'll do that. So bison, and what am I referring to? Well, we've got all these parts as int float boolean. There's going to be a percent token, and it's okay. Semicolon. There we go. And we don't need to give it a precedence, just because this will work just fine without precedence. And we're going to edit now flex. And so we need to tell it when we see a semicolon. I don't think, let me check my notes. I don't think I have to escape the semicolon. Looking. Should be in here somewhere. I do not. Don't have to escape the semicolon. Okay. So where are we going to put it? We'll put it right here. So when I see a semicolon, we're going to return a Tang parser, make semicolon with Tang location. Oops. Location. There we go. So when I see a semicolon, just tell bison. Okay, let's go back, and now we're in bison, and we have to decide how we're going to represent this. You see, there's two things. There's the idea of we could have a I think there's two types up here. So we're going to our types. We've got a program, which a program right now is just an expression. It's a pass-through. In fact, I can go down to it right there. It's either an expression or it is an end of file. Okay? Yeah. So it's like, wait, where did I go? Yeah. It's either an expression or an end of file. And we need to clean that up. A program can be multiple lines. So we need to either have multiple lines, or we almost need the idea of a code block. But you know what? I think we're going to hold off on the code block. First, let's... Yeah, we're going to do it like this. So I'm copying this here, and we're going to say, this is going to be a command sequence. Okay. And why am I, or do I want to? See there, and here I'm just arguing with myself, is that a good name for it? The idea is that it's a sequence of statements. So maybe statement sequence is better, or just statements. Statements, yes. Give me just a sec. I want to double check something that I'd done in the past. For now, I'm going to go with this. We're going to have statements, and we will have a single I should have just copied this. In fact, why am I not just copying it? There we go. Statement. A single statement. And you may say, well, what's the difference between a statement and an expression? Remember, an expression is kind of like a part of something. You know, 1 plus 2 is an expression, but the 1 itself is also an expression, and the 2 itself is an expression. And you put them together, and that's an expression. So it's an expression that is recursively defined. And a statement, then, is an expression that's followed by a semicolon. And then statements is a statement, so that's an expression followed by a semicolon, followed by another statement, which is an expression followed by a semicolon. So one or more. Yeah, I think I like that. So let's go down to our, what is our program then capable of being? Well, let's see. It's either an expression or let's do or statements. And if it's statements, then we'll just do AST is equal to $1. And now I have to say, well, what is statements? Let's do this here. Statements represent a sequence of do I want to say expressions, each of which ends with a period. Sure, why not? And what is the... Now, here's where we get into trouble. So, not really trouble. I'm just trying to think this out. Statement represents an expression followed by a semicolon. So let's do this one first. This one's easier to reason about. And we're going to say, so this is a statement, and what can it be? It is an expression followed by a semicolon. Now you say, why am I doing it this way? Well, because actually, I'm just going to leave it at that. You say, why don't I have to do this, open brace and close? Because the default behavior will be, what would it would look something like, $sign is equal to $1. There. It's just a pass through, which whoops. How about D2? There we go. Yeah, that will work. And maybe we don't even need statement, but represents a sequence of . Maybe I don't. In fact, I don't think I don't think I need statement at all, and I'll show you why. So we're going to come back down here to 184. Control up. I think I'm going to remove statement. There we go. 183 now. There we are. Okay. And we're going to say statements is, and it could be one of two things. It could either be an expression followed by a semicolon. And this is a recursive definition. And I know I'm not filling out the other part yet. Or it could be a I'm sorry, my brain just went dead. I know it. No, it didn't go dead. I knew what I was thinking. I'm thinking about, well, is this the only thing? Well, an expression always is a statement only possible. I'm adding back in the statement. Okay, the reason is because a statement may be more than just an expression with a semicolon. Think of an if statement. An if statement, it doesn't have a semicolon at the end. A while statement doesn't have a semicolon at the end. So a statement itself could be more than one thing, but it's different than an expression. An expression is something that is, again, it's, recursively defined within, a lot of little parts that can add together. However, a statement is fundamentally different. So I'm going to say here, statements, it is a sequence of I don't have a better way of saying that. Statement expressions. There. How about that? And so statements, it could either be a single statement or it could be, and this is where it's going to look weird. It could be statements followed by a statement. And this is true, right? That is, so the idea is that, let's start with this one. I didn't mean to do that one. I meant to do this one. There we go. If I have this, I'm going to say recursively that statements itself is is that the best way of doing it? Again, I'm arguing with myself. In fact, I'm going to look really quickly, because I've solved this problem before, but in a completely different situation. Not solved it. The question is, do I want to keep it in this order, or do I want statement first? And the reason is because I want there to be a vector of AST nodes, technically shared pointers to AST nodes, that we populate, and that's what statements should be. Is when it comes out, it should be an AST node that is a code block. Sure, why not? We'll call it a code block. that is made up of these things. So when do we create that? And the answer is we should create it here when we get to the the base case of this recursive definition. And that's fine. I just want to see how I've done this in the past. I've used a wrapper. I don't think I like that. You know what? I'm going to do it this way. I'm going to say, so statement is going to be return, not return, is equal to a standard make shared AST node, and we haven't done this yet, but we'll say, do we want to call it code block or just block? I'll just call it block. A block. Okay, fine. And what are we going to pass it? We are going to pass it the $1 at 1. And so this is a code block that takes as its first item a shared pointer to an AST node and a location. All right, now at this point, statements is this. You always have to think of it. What will it ultimately be? It will ultimately be this AST node block. So all that we have to do is $1 represents statements, the plural, and that is a shared thing. And so now we just have to say what are its statements dot push back. So we're adding $2. So statements, yeah. The $1 arrow statements is going to be a vector of shared pointers to AST nodes, which is what statement is, a shared pointer to an AST node. Isn't that right? Yes, because that's what an expression is, a shared pointer to an AST node. I'm just thinking if there's anything else. $sign is equal to $1. All right. That looks correct, but now you say, okay, well, we've got this idea of an AST node block. We've got to create that type. So you know what that means. First, let's do the makefile. And an AST node right here. AST node block. And we just go down here, AST node binary. Let's start with this one. And we will, for lines 56 and 57, excuse me, we're going to substitute binary into block. There we go. Simple enough. And now do I want to copy something? Well, yes, I do. I definitely want to copy something, but which AST node. If I do include AST node, what do I have options for? Let's just do the AST node. Wait, no, that's going to have all of the all of the comments in it. AST node integer, sure, why not? To AST node block.hpp and copy source AST node integer to source AST node block.cpp. Okay, let's edit those over here. Include AST node block and source AST node block. There we go. Now we need to change out int integer for block and do that again for the capital integer block. And oh, is it not there? That's fine. Okay, so should have been a %s. All right. So let's clean this up. AST that represents a code block. And we're going to have, oh, we need to pound include vector. Pound include vector. And this is the statements included in the code block. There we go. And we'll just do this as a standard vector of standard shared pointers of AST node. We called it statements. Okay, now our constructor will take a single shared pointer to an AST node, and we're going to call that statement. Okay. Param statement. This will be a statement of the code block. Fine. Okay, is there anything else? I think we're good there. Now, we need to go into this one. We're going to have to do our substitution. Did I pound include memory? I don't know if I need to there, but there we go. So node block, this is going to be a what did I say this is? A shared pointer of class AST node called statement, and we need can I do it this way? Statements, the number, this is going to be a block, and then string out is equal to indent plus block. That's fine. For auto x in this statements, that's fine. So we'll iterate through them, and we will say string plus equals x arrow dump with indent plus that. So this is going to, for the block, everything that's in the block, it's just going to go through and dump it. And so for the compile, this will be interesting. We're not going to actually do anything ourselves. We're going to, for auto x, oops, colon, this statements, we're going to x arrow compile program, and now program dot, I shouldn't have deleted that. There, that's the easy way of doing it. So I want to program dot add bytecode uint 64t opcode pop. Say, why are you doing that, Corey? I'm glad you asked. Remember, so the problem is we want to pop everything except the last one. Everything except the last one. Yeah. So we need to change this a little bit. Let's do for int I is equal to 0, I is less than statements, and that's a vector. How do we get the size of a vector? I never remember if it's length, size, count, whatever. All these languages are different. C++ vector size. That's what I'm searching for really quickly. And it is indeed just size. Okay, while it's less than that, and I'm going to do size minus 1 plus I. The reason is I'm going to add that for each one, and then if statement size no, not that. Okay. X does not exist. It should be this statements dot back arrow compile. All right. I don't often add comments. Just because a lot of these are so short, it's self-evident. But in this case, I'm going to say all but the last statement, adding pop after the statement. There we go. Compile the last statement without a pop so that it is left on the stack. Its value is left and on the stack. There we go. Like I said, I don't normally put a lot of comments, but if there's anything like, it's like, why did I do this? So that I don't have to worry about it. Okay, so that's the compile. What do we do about make a copy? Well, we're going to make a shared, a new AST code block with what I'm thinking is we're going to have to copy everything. A vector doesn't... Oh, wait. Sorry, my brain just stopped working again, but how about I just undo that? So the question is it possible to just statements and rather than this being a shared pointer of AST nodes, can it just be a vector of shared pointers of AST node? We'll call it statements. There we go. So statements, and we're just doing this. Why are we doing it this way? Because at this point, do I even need make copy now since I'm using shared pointers? Maybe. I don't know. We'll leave it. But if I can pass it a vector of the shared pointers called statements, then I can just create one from the start. Yeah, I think I like that idea better. Okay. we're going to go back to the previous one, and now this is, it's going to be a standard vector of shared pointers of AST node. That's fine. This is now, it is the statements of the code block. That should be fine. Whoops. I'm going to there. They all say statements now. And at this point, I should at least be able to be saying make test watch. And I'm going to have to change that bison file. Yeah, it doesn't like that, but that's okay. Let's fix that. It doesn't like that I'm using an int. Fine. It's a size t. Oh, string out is equal to that. This should be out. There we go. S. That should be an X. And X is not declared in that scope. Of course it's not. Now, instead of X, it should be this statements sub I. And now we're about to go back to the bison file, which is buffer 4. And so let's see. This is statement should no longer be is that right? So in case you're wondering, where's Notepad? Say, Corey, I thought you did everything in Vim. I'm just wanting to show you something. And I don't have, oh, that's something else. That's all right. I don't have my drawing pad set up. I used to have that. So statements. There we go. So you can see it. If that is our non-terminal that we're looking at, and it gets replaced by a single statement because there's only one, that needs to be a vector of, yes. So statement, this needs to be a can I do it like this? I know you say, Corey, shouldn't you know this? I forget. It's a vector of shared pointers. That should be standard shared pointer. Do I even need that? Let's try not. Of shared pointers of type AST node. And we're just going to call that S. Okay? And there. And now S dot push back that. And now that is equal to S. Okay. There's probably a faster way of initializing it. In fact, I still like to do that. So we're pushing it back. So if it's a single statement, it's that is not what I should be doing, is it? S pushback there we go. Pushback 1. There we go, because that's the statement. Say, Corey, you're having issues. I know. I didn't think this through that closely. And then now we're going to make that, and we need the location. We'll say at 1. Sure. Okay, but what if, and that's if there's one statement, right? We create a vector of shared pointers, we push that onto the shared pointer, and now we, what am I trying to say? We push back the AST node block. So statements is a node block with that. But what if there's more than one statements? Right? So what if we have ultimately statement, statement, statement? Okay? So what if we've got that? Well, our base case is a statement. So what Bison is going to see is statements followed by the last statement. Is that right? And the last... No, it's not. It's going to see this. It's going to see statements followed by the last statement. So I think that this should be reversed. I'm sorry, I'm arguing with myself here. And like I said, I've solved this before, but I did it in a completely different way. I was using pointers, and I don't like the way I solved it before. So you know what? We could make our lives a lot easier if instead we said at 1. There we go. It's taking a while to get here. I'm going to say that statements is not a shared pointer. I mean, it's not an AST node. Going back up there. Oh, did I already pass it? Where is it? Where are my tokens? Oh. Rather than it being a shared pointer to AST nodes, I'm going to say it is a standard vector of shared pointers to AST nodes. Say, Corey, you're making it even more complex. Not really. Wait. I put it in the wrong place. It should have been statements. There we go. So statements is coming across as just a vector of all of those individuals. So a statement by itself is an AST node. It's a shared pointer to an AST node. But statements is just a vector of them. That's the goal. Okay. So let's go back down here, and now it makes more sense, in my head at least. So statement is going to be turned into statement. So statement is an AST node, and I need to turn it into a vector of that one AST node. So that's what I did. Okay? Now, at this point, what is statements? Statements is a vector of AST nodes that's followed by a statement. So I can just do statements pushback $2 and return 1. Yes. That is, excuse me, it's not $1 dot arrow statements because $1 is just a vector. That's it, because statements is a vector. So now I'm taking the vector and pushing back the statement that appears after it. Now we have our recursive structure, and I'm returning the vector back. So statements is always going to be a vector, and then we get up to the program, and it will say, oh, well, I'm just going to say it's a code block and pass it the vector. That's what I needed to do all along. Oh my. Okay. So now I'm going to go back to the AST node block HPP and CPP. And I just want to make sure this, what am I passing in? I want to pass in a const vector, and we'll say ampersand. It's still going to make a copy of it, but we're fine. It's not going to make 2 copies or something like that. And this will also be a const ampersand. Now let's fix the compile errors that I know are showing up over here. Oh, wait. Oh, no, I was going to say they're gone. Nope. That's fine. AST node block was not declared. That is an easy error. Going back to Bison, and that is buffer, whoops. Buffer 4. We just need to go node, AST node block. No match for operator equal for vector of shared pointer of AST node and a shared pointer to an AST node block. Where is that? Okay, so no match for operator equal. And so what's on the left-hand side? It's a vector of shared pointers of AST node. Oh, wait, let's just go to that line. So this is in statement. So a statement is okay, I said it wrong then. Wait. Say, Corey, I should have written it down. I'm sorry. Fumbling around here. A statement is just an expression, right? When I get that, it is an AST node. That's right. But when it's like this, yeah, what am I doing wrong? Oh. Here I'm trying to create the block, and I changed how I was doing that. It needs to be S, right? Because statements is just a vector, And so if I've only got one statement, I'm creating a vector with just one thing in it and returning the vector. Yeah, okay. Okay, it's compiling. Yay, the small victories in life. All right. So I know I probably confused you a little bit. I'm going to go back and let me say this is what I did. Because believe it or not, I do have a pretty decent idea. First of all, we've decided that statements is a vector of AST nodes. I know it's pointers to AST nodes, shared pointers to AST nodes, but that's what it is. Pointers to AST nodes. Okay. And then, but a statement by itself is just a pointer to an AST node. That's different from an expression. Remember, an expression is, it can contain, it's a recursive structure. 1 plus 2. 1 is an expression. 2 is an expression. The plus is an expression, right? It's a tree-like structure. And a statement is just saying it is an expression that is followed by a semicolon. That's what we're doing right now, right? There may be other statements later, an if statement, a while statement, things like that, maybe a ranged for statement. So, but yeah, so a statement is still ultimately just an AST node. When you get a bunch of those together, you get statements. And we are saying, but that is just a vector of those statements. Okay, so now if we go down to where we actually declared it, we've got all of these up here. First of all, we said, okay, a statement by itself is an expression. One possibility is it is an expression followed by a semicolon. If so, pass that through, right, up to statement itself. And if we haven't written any code that uses this, but oh well. So a statement could be, you know what? I'm just going to do it. I'm going to do it over here because I want two windows. And I'm going to edit test.cpp. And we're going to do, oh wow, so many. I'll do it here. That's fine. So test, and this is now going to be, it's not an expression, it is statements. No. Code block statements, sure. And we're going to have an auto p1 is equal to Tang base dot compile script. And what is it going to be? The first one, we're going to say 2 semicolon and nothing else. And now we're going to say expect it to be equal to a 2. That's what we think is going to happen. Now I'm going to have to exit this. But rather what I'm wanting you to see is when it sees 2 semicolon, well, a semicolon isn't part of the expression, so it only matches this down here. Expression, a 2 semicolon. That is a statement. Then a statement comes through here. So, okay, a statement, I'm going to have a vector of these AST nodes. That's the 2. And I'm going to return that up to statements. Okay, and then statements gets passed up to program, and that becomes a code block. And now if we say over here, cout p1 dot because that's a program, yeah, get bytecode. It should give us a compiled bytecode that is just integer 2, and that's it. It should be left on the stack. We're going to try this. I'm going to switch my windows around. Actually, I'm going to do the second one as well. I'm sorry. And we'll just do this as a P2, P2, and this will be a P2. And what this is going to be is true. And that should be a true now. And the 2 should no longer be on the stack. It should be an integer 2 followed by a pop followed by Boolean true. And that should be it. That's what I'm expecting for those 2. All right, now I want them to fail. So I'm going to do 1 and false. Hopefully that will make both of them fail. And we are going to make test-watch. And I'm going to open the program has no member. Is it dump bytecode? I always forget. You would think I would know by now. Do I have... Ooh, I do. Hey, program. Where's program? Get code, dump bytecode. Yeah, and the reason I did that is because get should... Maybe it should be dump code as well, but oh well. Dump bytecode. Test. Dump, and this will be dump. Okay. This is actually doing what I wanted, right? I know it said fail, but because I intentionally made it fail. It returned a 2, and it just pushed an integer 2 on. That's what it did. Okay, for the second one, pushed an integer 2, pop, push a Boolean true, and it returned true, right? Yeah, it returned true. So if I fix these tests... And that is true and 2. There we go. Now these are the 2 outputs. But here's what's funny. Now, by the way, once we've used a semicolon, we can't not use a semicolon. So if I do one where it's it'll break the system right now because I haven't written it robust enough that if it errors out and I try to execute it, it's not going to quite work. So we're going to hold off on that. But all right, so let's do one that's... We'll call this one 3. And I want to do, let's see, 3, 3. And what is this one going to look like? We're going to say 1 plus 2.0 plus 3 is less than -7. Put all of that in parentheses. And by the way, is equal to true, and then end with a 42. Now you might say, Corey, this should have all been optimized out. Optimization is later. What does the code look like? Put a 2 on it. Pop it off. Now, integer 1, 2.3. Add them together. Integer 3. Add them together. Add the result of, yeah, all of that. Integer 7. Do the negative. Do the less than comparison. Now push a Boolean true. See if they're equal. And then pop it. And then push an integer 42. And we should get a 42 out of it. Right? And yeah. I didn't put the right answer, but we are executing multiple statements. And while, yes, okay, I'm sorry. I know it took a while. And in fact, here I said I was going to show you. I want to go back to the grammar. And I'll do it over here. Open read only. There we go. The reason, I just want you to see how this is behaving with multiple statements. At some point, it's, in this case, it will find that there's a 42. And when it finds that statement, it will do this over here. That is, it's going to create a vector, push back that statement, that 42. And then, nope, I'm sorry, I'm saying it the wrong way. I'm sorry I said it the wrong way, because statement is the first one. It throws everybody off. It throws me off. It throws students off, and I have to remind myself when I'm teaching. By then I'm usually in the flow, but I haven't thought about this stuff in a year and a half. So when you're looking at these recursive things, it's like whatever's the last one. That means it got to it last, which means when you've got the single case, it got there first and turned that into a statements multiple, and yeah, it does it that way. So I'm sorry, the 2 is the first one, and then so that was a single statement, and yeah, it just keeps on pushing back. So 2 is on there first, and then it pushes back the statement that it found, which is this big statement here, which has all those parts in it. It pushes it back, and then that becomes statements. And then it says, oh, and I found the 42. So now we've got the statements that has the first 2 in it, followed by a 42. Yeah. So that is how this works. It either finds a single one, in which that's our base case, that's the first one, or it keeps adding 1 to it. You say, Corey, do we need this? Is this the only place? No. Think about it. We've got to, let's say you've got an array, right? And however you want to designate an array. Say you want to use the square brackets, right? Well, you've got to have an expression followed by a comma, followed by another expression. Same thing, it's a recursive structure. Oh, or what if we're talking about functions? You're calling a function, and you need to pass it multiple arguments, right? Same thing, it's a recursive structure. So we're going to see this recursive structure over and over, and yeah. Okay, so let's wrap all this up, because I know that you're probably sick of hearing me ramble at this point. And so let's exit here. I do want to do my make clean and make test. And while all at the same time over here, let's clean up some. This shouldn't have the extra line there. Oh, I shouldn't have that, whatchamacallit? The C out. It's like, why isn't it rebuilding? Because it didn't tell it to. There we go. All right, anything else? Make sure everything looks right. Okay. Sorry, just thinking out loud. Okay, or not out loud, evidently. I was thinking quietly. So git commit dash am, and we are going to, what did we do? We added semicolon statements. To the language. L-A-N-G-U-A-G. To the language. That's fine. Only 58 insertions. Still, we got 2,700 lines of code. That's fine. Did I forget? Oh, I forgot those two. Git add as include and source. Forgot the there. I'm sorry. Isn't that horrible? Remake it all. This is surprisingly slow on my laptop when I do something like that, so I'm glad it's fast here. Not make. Commit-m update documentation for episode. Yeah, I'm sorry. I've slept since then. 22. Episode 22. And of course, we can check this out. We're going to have our AST node block. We should have, yep. We've got all of our stuff. And yes, again, I stopped to think. Git tag -a episode.022, and our message is so.022. There we go. It is live. And with that, we have statements in our language. And that means we can now do multiple commands one after another. Right now, everything is kind of declaratory. We don't have any variables to hold state. for those of you who don't get offended by variables that have state. But we're about to add those variables, and why? Because it makes sense for most people to have programs in that way. So, yeah, that's going to have to be our next stop along the way, is adding variables and adding assignment statements so that we can say A is equal to whatever, and then come back with that B is equal to something else, and then we don't have any print statements yet. That'll be coming, but we're just not there yet, okay? But for right now, we can just use the last line to be a return value. Okay, so now that you put up with me for all of that on this Halloween night where I look like my chair, yeah, thank you for joining me. Have a great day. Bye.